Okay, let's talk about two words you probably use all the time: speed and velocity. They might sound like they mean the same thing, but in the world of physics, they're telling two very different stories about how things move. So, let's break down what's really going on.
You know that feeling, right? You're driving along, you see a police officer with a speed gun, and your heart skips a beat. That moment right there gets to the heart of our question: how do we actually measure how fast something is moving? That simple, everyday question is our starting point.
When we talk about how fast, our brain pretty much automatically jumps to one thing: speed. It's the big number on our car's speedometer, right? It's the stat we check when we're looking at a new sports car. It's just our go-to way of thinking about motion.
So what is speed, officially? Well, average speed is simply the total distance you've gone divided by how long it took you to get there. Now, the key phrase here is that it's a scalar quantity. That sounds technical, but all it really means is that it's just a number, like 60 miles per hour. It tells you how much, but it leaves out a critical piece of information: which way.
And the formula is as straightforward as it gets. You've got VAV for average speed. That little triangle symbol, that's the Greek letter delta. And in science, it's just shorthand for the change in. So the formula is just the change in distance divided by the change in time. That's it.
All right, let's make this real with a quick example. Picture a dog running around having a great time. It covers 43 meters in about 28 seconds. So, what's its average speed?
We just need to take those numbers and pop them right into our formula. The distance, 43 meters, that goes on top. And the time, 28 seconds, that goes on the bottom.
You do the simple division, and there you have it, 1.5 meters per second. That's how fast our dog was moving, on average. Pretty simple, right?
But hold on, here's where things get a lot more interesting. Knowing how fast is great, for sure. But what if it's only half of the story? What if we're missing a huge piece of the puzzle of motion?
And this is where our second key concept makes its entrance: velocity. The easiest way to think about it is this: velocity is just speed with a direction. It's speed with a purpose. And, as you'll see, that little addition, it changes everything.
Okay, here's the formal definition. Average velocity is your total displacement divided by time. Now, displacement is just a physics term for your change in position from your starting point to your ending point. And here it is, the most important part. It's a vector quantity. That means it has two parts: a magnitude, which is its speed, and a direction.
This slide just nails the difference. Speed is asking one question, how fast? But velocity asks two questions, how fast and in what direction? So saying you're going 100 kilometers per hour, that's a speed. But saying you're going 100 kilometers per hour north, now you're talking about velocity. See the difference?
Now, the formula looks almost exactly the same as the one for speed, but you have to look closely. See those tiny little arrows above the V and the D? In physics, that little arrow is the universal sign for a vector. It's a small detail, but it has a huge meaning. It tells us we're now talking about displacement, which has that direction baked right into it.
So how do scientists actually wrap their heads around all this? This is where it gets really cool, I think. They don't just use numbers and formulas, they actually draw a picture of motion. Let's take a look.
They use something called a position time graph. It's a simple idea, but it's incredibly powerful. On the vertical axis, you've got the object's position, and along the horizontal axis at the bottom, you have time just ticking forward. This graph literally lets you watch an object's journey unfold over time.
And if you take away only one thing about these graphs, let it be this: the slope of the line, how steep it is, that is the velocity. That's the secret. A really steep line means a really high velocity. It's that simple.
So, check out this example. We see a straight line sloping steadily upwards. This tells us that an object is moving away from its starting point at a perfectly constant pace. Because the slope isn't changing, we know the velocity is constant. Now what about this one? See how much steeper that line is? Well, that steeper slope means a greater velocity. This object is covering a lot more ground in the same amount of time. It's just plain moving faster than the one in the last graph.
Okay, let's pull all this back into the real world. Because, let's be honest, motion isn't always so neat and tidy. It changes. And understanding that difference between constant and changing motion is key.
This brings us to two main types of velocity. You've got uniform velocity, which is nice and simple. You're moving at a steady speed in a perfectly straight line. Then you have non-uniform velocity, and this is a big one.
Your velocity is non-uniform if your speed changes or if your direction changes. So think about a car going around a corner. Even if your speedometer stays at exactly 30 miles per hour, your velocity is changing because your direction is changing. This table has some perfect real-world examples. A car on a straight highway with cruise control set to 100 kilometers per hour, that's uniform velocity. An amusement park ride going in a perfect circle at a steady speed, nope, that's non-uniform because its direction is constantly changing. And how about a parachutist after the chute is open, falling at a steady rate? That's uniform velocity, constant speed, and a constant direction, straight down.
So let's end with one last question to bring it all home. When you pull out your map app and it tells you your ETA is 5 minutes, what do you think it's using, your speed or your velocity? Well, think about it. To get you to a specific destination, it needs to know more than just how fast you're going. It has to know which way you're headed. It absolutely needs your velocity.